All right, so we've looked at horizontal and vertical tangents, but what if you want to find the equation of a tangent line somewhere at some specific value of t? Well, in order to do that, you need this. And this is where the Leibniz notation becomes really helpful. The slope, just like always, is, and I've got a typo here, the slope, like always, is dy dx. That should be an x. And the Leibniz notation lets you break that up into dy dt over dx dt. Now, you can kind of think of this as being dy dt times the reciprocal of dx dt, which would be dt dx. And then these things cancel and give you dy dt dx. So let's use that to come up with the equation of the line tangent to this curve. All right, so the way I like to do this is write out dy dx is dy dt over dx dt. Then I'm going to work both of those out. So dy dt is going to be 1 over 2 root t. And dx dt from here is going to be 2t minus 2. So that's the formula there for dy dx. Now let's figure that out when t equals 4. Now you can use this notation if you want to. Dy dx evaluated when t equals 4. That's kind of like the bar you put on the end of an integral, of a definite integral, but we've only got one thing to plug in. So we're going to plug in 4 for this, and we'll get 1 over 2 root 4 divided by 2 times 4 minus 2. So let's see, on top, that becomes 1 over 2 times 2, so it's a fourth. And on bottom, we've got, let's see, that's 8 minus 2 is 6. So 1/4 times 1 over 6 gives me 1 over 24. So a very shallow slope there. And now that's the slope of the tangent line. To actually get the equation, we need to find the x and the y value at that tangent. So maybe I should write this up here first. Find slope, and then find the point. Find the x and y coordinates at t equals, or maybe I should say when t equals 4. To do that, the x is going to be 4 squared minus 2 times 4. So that's 16 minus 8 is 8. And y is going to be square root of 4, which is 2. So I've got my x and y. Then we just need to plug in. So I get y minus 2 is 1 over 24 times x minus 2. So I get 1 over 24x minus 2 over 24 plus 2. So just this naked 2 over here is 48 over 24. So 46 over 24, 23 over 24. Is that right? Negative 2 over 24 plus 2. 23 over 12, yeah. That didn't sound right. Negative 23 over 12. And the cool thing with this is you can check your answer pretty easily. I'm going to go over here to Desmos and plug it in. Let's see. What was my curve to begin with? It was x is t squared minus 2t. And y was square root of t. And I'm just going to put in 0 to, let's say 0 to 6. So we get this funny looking curve. And when t equals 4, I'm just going to plug this in. When t equals 4, we found that the point was the point 8, 2. So see, we're looking at that point. And if I put in this line here, y equals 1 over 24 x, where am I typing into? Here we go. Y equals 1 over 24 x plus 23 over 12. It should intersect that point. And it doesn't. Why? Because somewhere in here, there's a small mistake. Let's go back and see what happened here. Somewhere in here, there's a small mistake. The slope doesn't look wrong. Let's see, y minus 2 equals 1 over 24 times x minus, that's my problem right there. I plugged in this 2. Let me make this a small eraser. This 2 right here was not supposed to be 2. It was supposed to be an 8. So let's just erase this stuff below and try this again. So I get y minus 2 equals 1 over 24 times x minus 8 over 24 is 1/3. Now if I add 2 onto that, I get, let's see, 2 is 6/3 minus 1, so plus 5/3. So yeah, my slope is the same as before, but my that changes my y-intercept to 5/3. Let's plot that and see what happens. If I change this to 5/3 over here, yeah, dead on. I go over here and I zoom way in on this. Well, let me change this to red. So the curve is red and the tangent is purple, and they're basically right on top of each other there. All right. So that's basically all you do there is you get the slope by using this formula up here. You get the point by using these. And once you've got those two, it's just like finding any other equation of a line.